A pleasant day, STEM learners. So this is now quarter one. I mean quarter two, week number one for angles in a unit circle. So for this week, we will talk about angle measure. So at the end of this video lesson, you should be able to define an angle in trigonometry and convert the measurements of angles from degree measure to radian measure and vice versa. So let's have an introduction to trigonometry. Migrating the understanding of trigonometry from triangles to circles opens its vast applications to other areas of science and engineering. During your grade 9 mathematics, you already had trigonometry about right triangles. But this time, we will migrate into another topic, which is the trigonometry of circles. So how do we relate this in science and engineering, which is also related to your strand, which is STEM? So observe how the tip of the hand of the clock behaves. In this lessons, we will be talking about circular functions. These circular functions are also the trigonometric functions that you already know during your grade 9 mathematics. Do you still remember the sine function, the cosine function, and the tangent function, as well as their reciprocal functions? We have the secant, the cosecant, and the cotangent functions. This time, we will be putting all those functions in a circle. That's why instead referring to them as trigonometric functions, we will refer to them as circular function in which they periodically repeat certain values. So that periodic behavior of circular function can be modeled through a natural phenomena, just like how the clock ticks. So imagine the rotation of the hands of the clock forming angles, and that is a natural phenomena that happens. Now, time is a natural phenomena in the universe. So let's proceed to the next part. So the Greek astronomer and mathematician Hipparchus is the one who studied the Earth as a sphere. And from that sphere, he defined angles inside. No? So he determined the radius of the Earth, no? The exact distance of the radius of the Earth. That is why Hipparchus is considered the founder of trigonometry. Okay, so this is the photo of Hipparchus, and this is how he studied the sphere. So where does trigonometry came from? No? So which etymology could we refer to it? So trigonometry came from the Greek words trigonon, which means triangle, and metron, which means measure. So it is a branch of mathematics that studies the relationship between the sides and the lengths of triangles. So a lot of people think that trigonometry is the study of right triangles only. Actually, it is not, because trigonometry is also the study of oblique triangles. It can also be the study of the triangles inscribed in a circle. So many of you might be confused that these triangles only compose of trigonometry. No? But we can also study trigonometry through the use of circles, just like how Hipparchus studied it. Okay, so it also involves other geometric figures aside from triangles. So it was mistakenly denoted just for triangles because of the word trigonometry, but that does not only mean that we are only referring to triangles. So trigonometry simplifies the mathematics of triangles, making astronomy calculations easier. And because of the angles of elevation and angle of depression, astronomers were able to get the exact distances of how far the heavenly bodies either inside the solar system or the heavenly bodies or the exoplanets outside the solar system. So we can easily compute for their distances based on how they view it in a telescope. So that's how amazing trigonometry is. So in geometry, the first concept that we usually learn are the undefined terms, the points, line, and the planes. And of course, one of the defined terms is what we know as the angle. So as you could see my hand, the angle could be formed by the union of two rays with a common endpoint called the vertex. So that is how we define the angle in geometry. But in trigonometry, we will have a different perspective of how you should understand angle in pre-calculus. So what is an angle in trigonometry? Because we already have defined an angle in geometry. So an angle in trigonometry is formed by rotating a ray about its endpoint. Observe how these angles rotate. So there are two possible rotations. It could be from the initial side going to a terminal side. The rotating ray is what we refer as the terminal side, while the starting point of a ray is the initial side. So an angle is said to be positive if the ray rotates in a counterclockwise direction. So it behaves the opposite of how the clock behaves. While the angle is said to be negative if it rotates a clockwise direction. So if it follows the behavior of how the clock moves, then the angle form is negative. So again, this is quite an interesting definition of an angle, because what we have learned during our grade 7 mathematics is that angles are only what? They are positive. What we know are acute angles, right angles, obtuse angle, straight angles, and reflex angles, which are all positive. But we will have a different perspective of angles because this time we will have angles which has negative measurements, and it will depend on the rotation of a ray. So again, if it is counterclockwise, we form a positive, and if it is a clockwise direction, we now have a negative angle. So this is how we relate the initial side and the terminal side and look at the rotation of a positive angle and observe the rotation of a negative angle. Now, is it possible really to input a negative angle? Yes, in trigonometry, it's possible. So that is how we view an angle in trigonometry. The first type of angle that you need to learn are what we call the angles in standard position. So an angle in standard position can be considered if and only if it is drawn on the Cartesian plane. So this is the first requirement. For an angle to be considered a standard position, one must draw it on the Cartesian plane. Aside from that, the vertex of the angle must be at the origin of the Cartesian plane. And look at this one. The initial side must be on the positive x-axis. So as you observe, if I'm going to draw the x and y plane or the Cartesian plane, this is x and this is y. If the angle is formed here and this one, or let me use another color. This is not an angle in standard position. Again, this is not an angle in standard position. Why? because the initial side is not the positive x-axis. So all the angles in trigonometry must start here as the initial side. And if you will put, for example, a rotating ray here, there are two possibilities for the angle in standard position. Either it will rotate in a positive direction, or it will rotate in a negative direction. So these are the two possibilities. But all angles in standard position must start here. Okay? So again, the key requirements for an angle in standard position must be on the Cartesian plane. Second, the vertex must be on the origin. And third, the initial side must be on the positive x-axis. Next definition that we need to learn is a unit circle. So as I told you a while ago, we are now migrating from the trigonometry that you know about triangles. This time, we will talk about the trigonometry involving circles. And the first defined circle in trigonometry is what we know as a unit circle. So a unit circle is a circle whose center is at the origin with a radius of 1 unit. So as you observe, our R here is 1 unit. And we will be forming a triangle here, a right triangle, inscribed in a circle with the angle, the reference angle here. And we refer to this one as theta, which is the angle in trigonometry. So this circle represents a unit circle because all radii of this circle is 1. So therefore, going back to the standard equation of a circle, x squared plus y squared is equal to r squared. So that will become x squared plus y squared is equal to 1 squared. Simplifying 1 squared, we will have 1. So therefore, the standard equation of a unit circle is x squared plus y squared is equal to 1. So we go back to the conic sections. Do you still remember this one? Standard equation of a center of a circle, center at 0, 0. So inside the unit circle, we form a what we call a central angle, because all of the angles formed here, in which one of the sides is the axis and the radius is what we call the rotating ray, forming the theta, which is a central angle. So central angle could be measured using degree measure. I know that you are familiar with the degree measure, and a degree is written like this. So this is 1 degree, and there are smaller units for a degree because 1/60 of 1 degree is 1 minute. So this is the symbol for a minute. And 1/60 of 1 minute is equivalent to 1 second. So those are the units of measure for degree. Aside from that, there are 3 units of measure for angle measure. So we have the revolution, the degree measure, which you are all familiar with, and radian measure, which I think were introduced to you during your grade 10 mathematics. I know you are familiar with the radian. So a revolution, it's like a full rotation. So when the initial side starts with positive x-axis, it will have 1 complete rotation, which is exactly equal to 360 degrees or in 2 pi radians. Okay, so consequently, the terminal side will now coincide again with the initial side. So it returned back to its original position. So that will be a 1 complete revolution. So it was the Babylonians who used this system, which is what we call the sexagesimal numeration, in which we use it now in determining the time on Earth. So the time in hands of the clock are related to how the angles also behave. So here are the conversion factors. So a revolution is equal to 2 pi radians, and 1 revolution is also equivalent to 360 degrees, which is also 2 pi radians. While a degree is equivalent to 60 minutes, and a minute is equal to 60 seconds. So therefore, there are 3,600 seconds in a degree, because that is 60 times 60. Now, to convert a region measure without pi, one region is approximately equal to 57.3 degrees. So a central angle of a unit circle with length 1 unit is said to have a measure of 1 radian, written as 1 rad. So how do we convert a region measure to a degree measure and vice versa? So here are the steps. So to convert a degree to radian, we simply multiply by pi over 180. And to convert a radian to degree, we multiply it by 180 over pi. Let's have illustrative examples. Example number 1. Express 75 degrees and 240 degrees in radians. So here's the hint. So to convert a degree to its radian measure, we need to multiply it by pi over 180. Now let us answer the first given angle. So we have 75 degrees, multiply it by pi over 180 degrees. You can simplify it by dividing it by the greatest common factor of 75 and 180. So the greatest common factor is 15. So we have 75 divided by 15. So that is 5. And 180 divided by 15 is 12. Multiplying the remaining factors. So we have 5 times pi is 5 pi. And the remaining factor is 1 times 12. So we have an invisible 1 there. So we have 1 times 12 is over 12. Then do not forget the unit of measurement. That is a radian measure. So without the unit of measurement, your answers will not be considered. Always encircle your final answer. So I hope that is clear. Let's have the second example. So we have 240 degrees. Again, based from the hint, we have to multiply by pi over 180 degrees. So we determine the GCF. The GCF is 6, I think. So we have to divide by 6. So 240 divided by 6 is 4. 180 divided by 6 is 3. Then multiply the remaining factors. So we will have 4 pi over 3. And do not forget the unit of measure. That is rad or regions. Then encircle the final answer. So that is how simply we convert a degree measure to its radian measure. Let's have the next one. Express pi over 8 radians and 11 pi over 6 radians in degree measure. So our hint is to multiply by 180 over pi. So we will have pi over 8 multiplied by 180 over pi. Obviously, we can cancel pi and pi. So we will get 180 divided by 8. So you can directly divide. We'll have 22.5 degrees. However, in your modified assessment, you're instructed to convert 0.5 degrees into a degree minute second mode. In the calculator, you can actually use the calculator by clicking this part. If you have a Casio FX99 ES Plus, so there is a function there in the calculator with a symbol like this. It means the degree, minute, second button in a calculator. So if you press that one, then if you press 22.5 degrees and you press this one, then it will automatically convert into a degree, minute, second. So the answer is 22 degrees, 30 minutes. Okay, but how do we let us show how to compute it. So we will multiply 0.5 degrees and multiply it by the conversion factor. Isn't it that a degree is equal to 60 minutes? So multiply 0.5 times 60, so that is 30 minutes. So we cancel the degree measure. So this is the answer. That's why we have a 22 degree and 30 minutes, which is our final answer. So always convert the decimal part, but as I've said a while ago, you can use the calculator to solve for it. But manually, I already showed to you how to convert it. Let's have the next one. 11 pi over 6 radians. So we multiply it by the conversion factor, 180 over pi. So we cancel pi. And I think 180 and 6 has common factors divided by 6. So this will be 1 and this will be 30. And 11, the remaining factors are 11 times 30. So that is exactly 330 degrees. Do not forget to encircle the final answer. So here are the references used in this presentation. Did you learn something? So for our next video lesson, we are still on week 1, angles in a unit circle. We will talk about arc length and area of a sector. Again, this is Sir Peter, your pre-calculus teacher.